Um, Happy to be here. Thanks, Ruchi, for having me in this conference. Uh, can I share my screen, please, so that we can get started with the presentation? Let me know once you can see it.
Yeah, we can see it.
You can see it? Okay, perfect. So, hi, everyone. Uh, really happy to be speaking with you about confined spaces and the applications of drones in them. We're a company based out of Mumbai, India, and I established Volar Alta in Feb 2020, which was like a month before the pandemic. And our vision is to contribute to the health and safety of workers by bringing in the operational efficiencies and also contributing to reducing the carbon footprint through our drone inspections. So, we are specialists in conducting internal equipment and factory inspections using some specialized drones. We've come a long way, starting literally from scratch to having prestigious clients such as Lafarge and Holcim, TUV Rhineland, police forces, just to name a few. We're a Government of India recognized startup, and we've been funded by the Government of India as well as the Government of UK. Now, through the next 20 minutes, I will first cover the basics of confined spaces inspections and then walk you through some of the case studies that I have. Yeah, so let's first understand how confined spaces are inspected by using traditional methods, and then we'll see how drones complement in this scenario. Now, what is a confined space? It is a location that is substantially enclosed, although not always entirely, where serious injury can occur from hazardous substances or conditions within the space, such as, let's say, lack of oxygen. Now, it can be any place, including, let's say, a chamber or a tank, silo, pit, trench pipe, sewer, flue, or any other similar space. Now, for conducting these inspections in a traditional manner, before entering any confined space, there has to be one assessment which needs to be carried out, and you need to check for the following, right? So, number one would be what is the task at hand. Number two would be what is the working environment. Number three, what are the working materials and tools inside the equipment that are required. Number four, what is the suitability of those who are actually going to carry out the task. And number five, arrangements for some emergency rescue. Now, as they are so dangerous, it has to be noted that entry to confined spaces must be the only and the final option to carry out the repair or the inspection work. And then, if you do decide to enter finally, you need to have something called as safe systems of work. That is, there should be a supervisor, the person should be medically fit to enter the space. You have to ensure that the mechanical and electrical isolation of the equipment is done well in advance. You need to ensure that the equipment is cleaned before the entry. We need to check the size of the entrance. You need to provide for ventilation, protective gear, breathing apparatus, lights, ropes, communication systems, emergency procedure, and the list just goes on and on. So it's a very tedious process given the serious consequences in case something goes wrong. Now, what can be these consequences, right? It can also be fatal, but other sorts of consequences include serious injury due to fire or explosion. There can be loss of consciousness because of, let's say, increased body temperature. There can be drowning because maybe some level of liquid has suddenly increased. There can be asphyxiation, arising from, let's say, vapors, gas, fumes, or just simply lack of oxygen, etc. Right now, usually these kind of consequences arise because of the following hazards. So there can be some flammable substances, there can be excessive heat, there can be toxic gases, there can be some ingress or pressure of liquids, etc. So now that we have set some context as to how difficult and time taking and most importantly life threatening confined spaces inspections can be, let us look at the roles that drones play here. Now we all know that there are two main types of drones. One is internal inspection drone and the other one is external. As the name suggests, the external drones will fly in the airspace, whereas internal drones will fly in confined spaces, right? Let me consider confined spaces, and the drone that I will be talking about is Helios 3 by Flyability. I'd like to highlight about five things about this drone. Apart from having high quality optical and thermal sensors, the drone is number one, it's collision resistant. That is, it is housed in a cage, so it can basically go very near to the walls of the equipment without really causing any harm to it. Second is, of course, it has confined space accessibility. that is, it can fly where no other drones can fly. Number 3, it has a robust transmission in terms of going beyond visual line of sight and conducting the inspection. Number 4, it has its own lighting system. And number 5, it's tiny. So all you need is like a 42 centimeter opening inside the equipment for the drone to enter. The important thing, however, to note here is that this drone can operate only in environment wherein the temperature has been brought down to less than 50 degrees. As compared to external drones, this particular drone operates on radio frequencies instead of GPS. And of course, like I said earlier, it's not dependent on natural light since it has its own light sensors. The commonalities between the two would include compatibility with multiple sensors, as well as the fact that we can also extend the range of both external as well as internal kinds of drones. Just to show you a point of difference between the kind of output that is collected. So we've done both internal as well as external inspections, and on the screen is what you see, the different kinds of outputs that we get. On the top left are the pictures of damaged portions of the refractory. On the right is an example of construction progress monitoring, and on the bottom are examples of volumetric analysis, thermographic inspections, and so on. Now let's understand who are the beneficiaries of confined spaces. Where do we deploy our drones for confined spaces? Basically, any industry that has a manufacturing setup with equipment like chimney, boilers, cyclones, tanks, etc. So this means that any industry which requires to subject human beings to conduct scheduled maintenance activity in confined spaces would be our target industry. So therefore, what kind of industries come up to our mind? Cement, chemicals, power, maritime, defense, oil and gas, etc. Why? Essentially because A, they have set out on a digital transformation journey, and 2, drone-based confined spaces inspections play a big role when it comes to conducting their scheduled maintenance and inspections process. Why are drones so important? Simply because they not only reduce the turnaround time for inspections, but they also significantly reduce the costs, carbon footprint, and potentially save lives by restricting human entry into these confined spaces, right? We operate pan-India mostly in the showcased industrial clusters. Now let's try to understand what kinds of equipment are inspected and what is it that we usually find. So at Volar Alta, we've inspected about 400 different kinds of equipment across multiple industries. When we inspect a few of the equipments mentioned on the screen, such as tanks, chimneys, cyclones, we look for defects such as, let's say, minor cracks, if there is any corrosion problem. We can also check the temperature profile by using thermal sensors. We can also find out if there is any product buildup on the walls of the equipment. We can find out if there are any broken parts inside the equipment. We can check the entire structural integrity of the asset. We can conduct some volumetric analysis. We can find out more about if there has been any delamination, if there are any leaks, blockages, etc. So these are the common kinds of defects that we find during our inspections. Now I'd like to just play a small video for you to understand what exactly happens. I'm just going to increase the speed a little bit so we'll be able to see most of it. You're able to see the video, right? I think so, yes. Okay.
Yeah.
So let's start with chimney. One of our customers wanted to check the refractory condition of an 80 feet chimney. Had he gone the conventional way, he would have lost about 3 days in only erecting the scaffolding and another 2 days to conduct the manual inspection. By deploying our drone, we finished the inspection in just half a day and saved the customer about 5 days of downtime. As you can see here, the optical sensor is dust proof and the lighting system is as good as daylight, giving you a clear 4K resolution imagery and video footage. Coming to cyclones, one of our customers wanted to inspect about 64 cyclones. By the conventional method, they would have required about 6 days to erect the scaffolding and another 5 to conduct a manual inspection. The interesting thing here is that we finished inspecting all of the 64 cyclones in just 3 days and found issues with only 6 of them. So what does this translate into? It translates into direct savings of about 2 crores for scaffolding costs for those 58 balance cyclones, and also reduced inspection related downtime by about 8 days. So that's a huge saving for the customer. Now, given that there are various types of equipments across industry verticals that our drones can inspect, I would like to pick boiler and tell you a little bit more about that. Now, most boiler inspections are conducted on an annual basis, right? So this means that if there is any issue in your boiler, it can go undetected for a really, really long time. Now, while these issues may not immediately impact the life of the asset, but it can lead to problems such as, let's say, leaks or other emission related problems that can have a negative impact not only on the asset and the plant, but also on the environment. With our drones, it takes about an hour to complete the inspection of a boiler. The drone goes inside through the manhole and gathers visual data of the entire equipment. It has a cage to protect itself from colliding with the equipment. Now, there is another interesting fact here. There was one study which was conducted by Boiler Room Consulting, and they found out that increased inspections supported by collision tolerant drones such as Helios 2 can reduce the carbon dioxide emissions by about 442 to 600 metric tons a year. That is a huge reduction, and that too from just one single boiler. Now, the data collected from the regular inspections can also, complement your condition monitoring or also act as inputs for predictive and preventive maintenance. I will move on to talk about the value drivers and ROI. So, when anybody considers deploying drones, the first thing anybody would look at would be what is the return on my investment by deploying drones, right? So here there are multiple returns that you're getting from one single tool. Of course, the most important one being that there is a 100% increase in the safety of your inspections. There is a 100% increase in the accuracy of the data that is collected. You end up digitizing the entire workflow. So you can just go back to the click of a button and find out the entire history of what has happened with the equipment. Apart from that, now this is a data point that I'm talking from our own inspections and our own data sets. So we've seen that on an average, the number of days of shutdown required for an equipment or a plant, right, is about 17 and a half days if you go by traditional methods of inspection for whatever industries we have worked in. By deploying drone, that average of 17 and a half days basically comes down to less than a day, right? So again, you see that this is a huge reduction, and you have a minimum 96% reduction in this downtime and time required to actually conduct these inspections. Then if we come to number of hours saved, right, again 96% reduction in the time taken. If we look at manpower cost, we've reduced that to by more than 86%. And of course, there is a 100% saving in equipment cost, 100% reduction in the hazards, etc. Right? Now, the additional benefit here is that if you do your inspections at a regular interval, you're basically keeping the asset healthy, and which in turn contributes to reduction in the greenhouse gases and the carbon emissions. So there is a clear ROI on the investment that our clients are making in terms of deploying these kind of drones. So now, how do we do it? Well, there are three aspects to the inspection: drones and skilled pilots, processing and analytics, and finally the workflow management. I've already spoken about the drones. Just to give you a brief about how we do it, well, you need a very, very skilled pilot to conduct these inspections. So there are two people who go on the site. One is a main pilot and one is a co-pilot to carry out these inspections. There always has to be a site engineer present next to us. So, in case of any emergency, we, know how to handle it. Once you've collected all the data, you need to first process it and then analyze it in order to identify the defects and points of interest. Thereafter, a report is shared with the customer about whatever it is that we have found. Now, all this is made seamless by using our workflow tool. Considering that every minute during the shutdown is a costly affair, our own workflow management tool will enable our customers to take some time critical decisions on the spot by assigning the next steps to the relevant person as soon as the inspection is complete. It also helps our drone pilots to follow procedures and update the analytics real time on the software. So essentially you get a complete digital visualization of the inspection that we have just carried out. Until now, I have basically shown you at a macro level. I would like to now deep dive industry wise, what it is that we can inspect and what it is that we can find. So let's start with chemicals. You can fly between the indoor pipe rack, cables, and conduits in a production facility to check the integrity of the welding, as well as detect any potential leaks. By increasing the, if you go to fermenter tanks, for example, increasing the quality of batches systematically by, let's say, inspecting the shaft and blades of fermenter tanks in an enzyme production facility also helps you to keep the health of the asset in check. We can also inspect some decommissioned pressure vessels. We can inspect some storage tanks. The drone can also fly inside the suction ducts, etc. So I see that it's already 10:40 and I have about 2 to 3 more slides to cover. However, I'll ask Ruchi if I can take another 5 minutes, or then we can open the floor to questions. Whatever works.
We have time, Niharika. We have a buffer time as well now, so it's okay. You can carry forward.
Okay, perfect. Thanks, Ruchi. So, coming to heat exchangers, well, this is an important one. You can look for tubes clogging of a heat exchanger, let's say of a soda ash plant, while piloting beyond the line of sight from outside the heat exchanger. We can check the actual cleanliness. We can assess the amount of the remaining product in a, let's say, recently cleaned soda ash silo. We can look for a product buildup as well as evaluate, let's say, the integrity of the gauging cable in the storage bin, etc. Moving on to oil and gas, we can inspect chimney or smokestack by performing a general visual inspection to detect anomalies like cracks inside of a sky-high chimney with, let's say, an oil refinery. We can look at, collecting some close-up images underneath a jetty to check the structural integrity as well as the integrity of the piping that it carries. We can also perform inspections in the refinery segment, wherein we can check the production units of petroleum refineries like, let's say, fluid catalytic cracking and cokers, etc. Moving on to power and other utilities. There are coal-fired boilers, right? So you can check the integrity of the burners, superheaters, and pipings inside the combustion chamber. We can detect the clogs and wear and tear inside all of these preheaters, etc. Apart from that, coming to wind turbines, we can also inspect the blades of the wind turbines during plant shutdowns inside the pillar and basement of the turbine while operating. So for wind turbine, there are two kinds of inspections, right? External as well as internal. So this one is specifically for internal. When you do external, you basically collect RGB images of the blades, and sometimes you also take thermal images and find out if there are any inconsistencies or any delamination which is present in the blades. I will quickly move on to mining now. In mining, mostly the kind of demand that we have is for conducting volumetric analysis of the material that is inside the shed. Apart from that, we can assess the integrity of conveyor belts without really having to power them or power them down, or basically to stop the ongoing excavations. Apart from that, we can explore some restricted areas such as excavated open stopes. We can look at, we can get inside of a sag, ball and grinding mill. We can also perform some preventive maintenance of crushers, etc. Moving on to maritime and other segments here, we can remotely perform the visual inspections of maritime vessels such as ballast tanks, fuel tanks, etc. Apart from that, we can inspect some steel mills. In steel mills, basically blast furnaces or cranes or crop shears, etc. Apart from that, if you look at factory sealing, this is another interesting application that we have. Where there are assets which are so huge that for years together the factory sealing inspection has not been conducted because of the challenges that traditional inspections bring along. But we are able to do that in less than half the time without really shutting down the production. So, that's great. And finally, with cement, I think I've already spoken about silos and tanks and chimneys, conveyor belts, etc. So maybe I will not, again talk about that. So this was in brief about the kind of applications that we have across industries. And thank you, Ruchi and Satvik, once again for having me in this conference. And it has been lovely to share my experiences with you. If there are any questions, I'll be happy to answer now.